Okay, so this video we're going to examine more applications um, of mixing quantities. So in this one it says Ruth runs a coffee house where chocolate almond coffee beans sell for $7 a pound and hazelnut sells for $6.10. Customer asks Ruth to make 6-pound mixture, 2 kinds of beans. How many pounds should be mixed if the cost is to be $6.40 per pound? So again, I'm going to use a table to solve this. So we have 2 kinds of coffee, almond and hazelnut, and we have a mixture. And so the first number we come across is that $7 a pound, and so $7 is the amount the almonds sell for. So I'm going to put $7 right there. So that's a cost per pound. And then the second number we come across is a $6.10, which is what the hazelnut sells for. A customer asks Ruth to make 6 pounds of the mixture. So 6. So this is the total weight. So we want a 6-pound mixture using the 2 kinds of coffee. How many pounds of each should we mix? Okay, if the cost is to be $6.40 per pound, so the mix cost is supposed to be $6.40. And we don't know, what we don't know is that. And the cost of each part is going to be 7x and 610y. And over here, the cost, we can figure out the overall cost by multiplying those two. So 6 times $6.40 would be $38.40. So again, two variables we don't know. So we would need 2 equations. What are the 2 equations? X plus y equals to 6. And then 7x plus 610y is equal to 38 and 40. And we can solve this again using either substitution or addition. I'll go with addition on this one. So it's all nicely lined up. So I'm going to make the y go away. So I'm going to multiply this by negative 610. That's going to give me negative 610x, negative 610y equals to 610 times 6, negative 36.6. And that second equation, I don't have to make any changes. So it's going to be 7x plus 610y equals to 3840. Now, if you were to add these together, so that's 90 right there, 0.9, excuse me, 0.9, and the y's cancel out. And over on the right side, we have 3840 minus 36. 3840 minus 3660. Getting fat fingered over here. 3840 minus 3660. 180. If I divide by 0.9, I get x as 2. Okay, so what does that mean? So we need 2 pounds of the almond coffee. So 2 pounds of the almond coffee. And then that would mean we need 4 pounds of the hazelnut. Another problem of the same kind. So Gene owns the nut shop where walnuts cost $6.80 a pound, almonds are $6.40 a pound. Gene gets an order that specifically requests 30-pound mixture that costs $6.65 a pound. Okay, so we have almonds again, and we have walnuts. Alright, so and we have a mixture. So walnuts cost $6.80 a pound, so $6.80. So this is the cost per pound. And the almonds cost $6.40. Okay, she gets an order to mix 30-pound mixture of walnuts and almonds. Okay, so the mixture is 30 pounds. This is the total weight. And she also is told that the cost per pound cannot exceed $6.65. Alright, what we don't know are the weights of the almonds and the walnuts. So I'm going to call that X, and I'll call this Y. And so the cost for each part is going to be 640X and 680Y. And over here, it's going to be 665 times 30, which is going to be 199.50. So again, we need two equations. So we can say that X plus Y is equal to 30. And then 640, the cost of each piece, plus 680 must be equal to the cost of the overall piece. I can use either substitution or elimination. Since I used elimination on the other one, I'll use substitution on this. So let me take that first equation and solve for y. So I have x plus y equals to 30. So y would be 30 minus x. So I can put that in here instead of into the second equation instead of y. So we get 640x plus 30 times 680. So let's distribute here. That's going to be 204 minus 680x equals 199.50. Let's clean up the left side. So 6.40 minus 6.80, it's going to give me 0.04x plus 204 equals 199, and minus 204, that's going to give me so 199.5 minus 204, that's negative 4.5. So divide both sides by negative 0.4, and negative over negative is positive, so 4.5 divided by 0.4, I get 11.25. So let's connect this back to the problem. So pounds of almonds, we need 11.25 pounds, and for the walnuts we would then need, since it's a 30-pound mixture, we would need 18.75 pounds of walnuts. So, all right, that's it.